This is Mrs. Robert. So you should have already gone through the first part of learning target 3, which was using the triangle sum theorem to find some interior angles of triangles. And now we're going to start with just an exploration of some interesting things that you'll notice about an exterior angle with relation to some of the interior angles. So first of all, the problem we're going to explore is it says find the measure of angle 4. So that's this angle out here. This is called an exterior angle. If measure of angle 1 equals 50 degrees and measure of angle 2 equals 60 degrees. And so without looking further ahead to do this problem, you might start by saying, well, I know that angle 1 plus 2 plus 3 are interior angles and they should have a sum of 180 degrees. So 50 plus 60, we have 110 degrees towards our total of 180. So if I take that away from 180, that tells me that angle 3 should be 70 degrees. Well, then from there, you can look at the linear pair involved with 3 and 4, and you could say that 180 minus 70 gives me 110, so measure of angle 4 is equal to 110 degrees. So that's kind of a lot of steps, right? It's not hard, but there's a lot of steps involved. Let's think about that relationship in a quick way. Did you notice that this 110 showed up along the way in our calculations? In fact, when we added 50 plus 60, we got 110. That was not a coincidence. That actually is something called the exterior angle theorem. It says if you want to find an exterior angle, like angle 4, you can just add the two angles that are not touching angle 4. They're called remote interior angles. So angle 1 and angle 2 have the term called remote interior, but basically they're the two angles that don't touch angle 4. And if you add them together, you'll always get angle 4. And so I want to look at one other example before we jump in. So let's say we have angle 4, and let's say some of these other angles are like 20. It doesn't really look like a 20. Let's make it an obtuse triangle here. So let's say this angle is 100 degrees. This angle over here is 20 degrees. And we're trying to find the measure of my question mark. According to the triangle sum theorem, we can just do 100 plus the 20, and that is the answer for that question mark. Now let's double check that it works. 100 plus 20 is 120. If I take it away from 180, I get 60 degrees in that spot. But then notice, the angle we were looking for is supplementary with the 60, so 120 would work because they sum to 180. And so there's another verification of the exterior angle theorem with numbers. We're going to a lot of times use this theorem with algebraic expressions. So you can notice that we have an angle out here labeled 5x minus 60. Well, that's going to be my exterior angle. And then we have some angles labeled on the inside, the 15 and the 2x plus 3. Notice both of those are our remote interior angles. They're the ones not touching. They're not in the spot where I put my question mark, right? So those are the two that would add to equal the exterior angle. So I should be able to say that 5x minus 60 is equal to 15 plus 2x plus 3. I'll put the little parentheses around them to start with, but it's not really necessary. So it's kind of like saying measure of angle 1 plus measure of angle 2 equals measure of angle 4. We're skipping or bypassing this angle over here at angle C that we don't need. And then from there, it's just algebra. So let's combine some like terms. So the 15 and the 3 can combine to give me 18. And then I can subtract the 2x to get all the x's to one side. And at the same time, I'm also going to add this 60 over. So I end up with 3x equals 78. So then x equals 78 divided by 3, which is 26. And so the question said find the measure of angle B. And so angle B was this 2x plus 3. So now that we found x, we can plug it in. 2 times 26 plus 3 gives me 55 degrees. And then what's kind of neat is we can go in and check these. So if that's 55 degrees, let's also plug in the 26 to this blue angle, the exterior angle, and see if we get numbers that make sense. So 5 times 26 minus 60 is 70 degrees. So if I look at my picture, if I put a 70 out here, 55 and 15, let's see if these numbers make sense. So 15 plus 55 would give me a sum of 70. Those match. And if I did 180 minus 70, it would tell me that this angle is 110, which obviously my picture is not to scale. It was to begin with. But 110 and 70 do add to 180, so it makes sense. Our numbers check. And so, but our final answer up there, let's circle it, was the measure of angle B was 55 degrees. Okay, one other big idea today is something called the third angles theorem. This theorem is saying that if two angles of one triangle are congruent to two angles of another triangle, then the third pair of angles would also be congruent. So if you look at this picture, you can see that angle L and angle R are congruent, and angle S, or M, and angle S are congruent. And this theorem is just saying that if that's true, then N would have to equal T. And let's look at some numbers with that. It should make sense, but let's say if L is 60 degrees and M is, let's say, 40 degrees, and we could put those numbers over here, right? Then think about the triangle sum theorem says that 60 plus 40 is 100. If I take that away from 180, angle N would have to be 80. Well, we would do the same math in this one. 60 plus 40 is 100. Take it away from 180, and we get 80 degrees. So that's sort of proof that that works. And so basically, it's called the third angles theorem because if you know two of the angles, you'll know the third is equal as well. Or if two angles are congruent to two other angles, then the third is congruent to the third. And so let's take a look at this picture. So you can see two different triangles in this picture, and you can see angle at G and the angle at H are congruent. The angles at F are congruent to the angle at F is congruent to the angle at I. So that must mean that the angle at K, oh that's big, sorry. The angle at K should be congruent to the angle at J. And so we can say measure of angle J equals measure of angle K, and we can plug our numbers in. 4y squared, oops, I put that in a different order, sorry. I'm going to keep it like this. Measure of angle K equals measure of angle J. 4y squared equals 6y squared minus 40. If I solve this to get all the y's to one side, you'll notice I get negative 2y squared equals negative 40. Divide by negative 2, so that would give me positive 20. And then y would have to equal the square root of 20. We're square rooting both sides, which we all know, and it could be positive or negative, because when we take the square root of both sides, we could have both positive or negative options. Well, let's simplify this. So if we take our 20 and split it into perfect square number in another factor, we could use 4 and 5. So this would be plus or minus 2 root 5. So we really have two answers here for y. But the question is not asking for y. The question is saying, can you find the measure of angle J and the measure of angle K? And so let's go and plug those back in. 4 times y squared, so 2 root 5. Whether it's positive or negative, we're going to square it anyway. And so when I square a positive, it's still positive. When I square a negative, it's still negative. So when I square this number, remember it's like 2 root 5 times itself, 2 root 5. So this becomes 4. And then root 5 times root 5 is square root of 25, which is just 5. And I still had the 4 on the outside. So it's 4 times 5. That's going to give me 80. You want to check my math. You could also check to see if you could just do that on your calculator. Kind of play around with that. You might want to pause the video. So it should be that that's 80 degrees. And we could do the same thing with measure of angle K, but I mixed that up. Whoops. That was measure of angle K. Sorry. But measure of angle J, you should also get 80. I wouldn't have to do the calculation, but if you want to check your work, you could plug it in just to make sure. I'm doing that on my calculator real quick just to verify it. And yes, I got 80 degrees. All right, there's some problems for you to try, all using the different things we've learned. I'm going to pause or stop my video. Maybe I'll make another video that has the answers in it, or you can check with your teacher.